welcome my own students for this session. And after the session, we will have discussion to take this association further. Whatever way, let's see, we will work it out. So I'm taking my seat and leaving it to you for next 1 hour. Give us some inputs which will be beneficial for the students, for us. So we are here at Delhi Technological University, which is a university in Delhi. It's a state university fully funded by. We are having a very good lush green 160-acre campus. So maybe next time, if you are able to manage to come to the campus, you will find a very neat and clean. And we are having a student population of around 15,000.
Wow.
It's a
big institution, yeah.
Yeah, fairly big institute as compared to India standard. As compared to US standards, it's not that big. So it's a good campus. So now please carry forward and whatsoever is there. Okay.
Sure.
Thank you.
Thank you, sir. I will can you see my screen?
Yes, your screen is visible.
Okay. So good morning once again. Thank you, Dr. Garg, for inviting us, and also Mr. Arunjit Chaudhary, for managing this, right, and arranging this session. So a warm welcome to all the students for this session. In this session, I'm going to be talking about machine learning as applicable or as relevant for the mechanical engineering discipline. And I will also be introducing AutoML, as a discipline, right? That is automation of ML. That is of lot of relevance for the mechanical engineering industry and also for the mechanical engineering students, primarily non-programming oriented students. Okay, so I will also give a demo of our tool, towards the end of the session. So before I begin, a brief introduction about myself. I did my engineering, from the 97 batch from South, from Guindy Engineering College, and subsequently did my MBA, and I have been working ever since. I'm currently associated with an artificial intelligence venture called Seaport AI. Arunjit and I, ABTS and I, we are partners in bringing technology and AI training, especially to college students. My interest is in the area of artificial intelligence and machine learning. I've also written books, both related to machine learning as well as management topics. Okay, I'm also a Lean Six Sigma Master Black Belt, trained by General Electric, the early 2000s. Okay, and I worked a lot, in Hewlett Packard. Much of my experience is in Hewlett Packard, where I set up a center of excellence for machine learning and data analysis. We call that as an analytics center of excellence, and also a fraud detection center of excellence, somewhere in 2010-2011 time frame. Okay, so this is about me, and I will get into the session. So I have structured this program. I will introduce some concepts, and after that, we will cover some case studies. Okay, that is the way I have covered. This slide that you're seeing is probably the most important slide, right? If you see, and this is a lot of relevance, to the mechanical engineering industry also. We are in the fourth industrial revolution, right? I'm sure all of you are aware, right? And if you see that the mechanical engineering discipline has been at the center of all activities, right? Mechanical engineering is the mother of all industries, right? Every industry, every innovation that happens, it needs to serve the core mechanical, electrical, and civil engineering disciplines. Only then we say that, it is applicable, because the rest of the industries are service industries. We start with, the industry 1.0, right? And then we have industry 2.0 and 3.0 and all that. Before that, before 1.0, I'm sure all of you know that there was only bullock cart, right? There was nothing else. Industry 2.0, right? The company that led the industry 2.0 is known as Ford. Okay, I'm sure all of you know Ford, right? Ford Motor Company. What is beautiful about 2.0 is before this, products were not made in large quantities. Mass production was not there, right? The concept of assembly line, electrical energy all came in 2.0, right? The concept of 8-hour work week, 8 hour in a shift, right? And 3 shifts in a day, 5-day work week, right? All these things happened in industry 2.0, and the company that led all this is Ford, right? We are reaping the benefit of it. Before that, there was no concept of you need to work for 8 hours in a shift and all that. Very fundamental, right? Very fundamental work that defined how modern organizations will exist, right? That is industry 2.0. Come 3.0, we have computers, right? That played a very important role, right? Until 3.0, right? A good part of 3.0, India as a country did not play an important role, right? It was purely led by America and the Western countries. However, in Industry 4.0, India is playing an important role, though it is West that is leading. There is no doubts about it, right? India is playing an important role, beginning to play an important role, right? Here we are talking of Internet of Things. And in an equipment in a factory is talking to another equipment in a factory, right? So these things are important developments, right? This is an equipment one, it is talking to another equipment. When I say talking, it is transferring information, and this information could be monitored sitting in a central place, and you could take action based on this. Okay, all these things are developments and advancements of industry 4.0. It is also augmented reality and virtual reality. I will share a video after my lecture as to how you can visualize things in 2 dimension, in 3 dimension, right? If let's say a big equipment is there, you are all sitting in a conference room, can I bring that equipment in 3 dimension into a conference room so you can see the entire equipment in all its beauty, in all its detail, sitting in a conference room, right? Sitting in Delhi university, right? You're not going out. That is the beauty of AR and VR. Huge relevance to the mechanical engineering discipline, right? So that is the beauty of industry 4.0. Of course, machine learning is the most important of all, right? Machine learning, this is the I will call that as the 5-star technology that all of you must understand, right? Because the industry is moving towards machine learning, right? Everybody must learn. Either you program or you don't use a program, but still you will use machine learning to solve your problems, right? So that is the beauty of industry 4.0. So let me ask I know I shared that, right? I know it's a small group. Can you tell which movie comes to your mind when you think of AI? Can anyone tell which movie comes to your mind when you think of AI? Right? Anything else?
I don't know even.
Okay. Anything else? There are a lot of movies, right? So we have Shah Rukh Khan's Ravan is there, right? Rajini Khan's movie is there, Robot is there. There is also a Steven Spielberg movie with the name Artificial Intelligence. Okay. Transcendence is another wonderful movie. Okay. iRobo is another movie. There are a lot of movies. So my question is, as something people you need to be aware, right? Is what you see in movies all about AI? Is what you see in movies, is that what AI is all about? If let's say you all choose to learn artificial intelligence, right? Is what you're going to learn is what is being shown in movies? That is my question. Or is it something else?
Something else.
What is that something else? Okay. To understand that question, what is that something else? You need to know two terminologies. Okay. One is known as strong AI and the other is known as weak AI. Okay. In strong AI, we are thinking of computers at the level of human beings, right? You know that, right? Both Rajnikant and Shah Rukh Khan, they displayed human emotions, right? They were actually singing songs with heroines, right? Both of them, right? Of course, Indian movies dramatized a lot. Even if you see the English movies, right? We are not there yet. Please note that. This is futuristic. Okay. So what you see in movies is not the current form of AI. Okay. We are not there yet. This is known as artificial general intelligence and artificial super intelligence. A lot of people are trying for it, right? Maybe it will take 100 years, maybe it will take 200 years, nobody knows, right? Yes. Okay. So where we are today is known as weak AI. This is the dominant mode of AI today. And what we are doing is we are solving problems by detecting patterns, right? So in the graph that you see in your screen, right? In the graph that you see on your screen, can you tell me the patterns that you observe? What are the patterns that you can observe? What are the patterns that you can observe, right? I have put 2010 to 2015, information is there, right? It's a monthly data. You have January, February, right? March, April, and you have December, then you have January. What are the patterns that you can observe? Can anyone attempt that? What are the patterns that you can observe?
Either big trend.
Right? What else? If you see, there are 3 or 4 patterns in this set of data. This can be anything, right? This can be, the sales of automobile, right? Let's say you are a demand planning manager in a mechanical, in an automobile company, right? You are the demand planning manager in an automobile company. You have to plan the parts requirement, you have to plan the inventory, everything that is going to go into the manufacture of automobile, right? You have to forecast because you are the demand planning manager. You can't say, to your other departments, sir, cars are not available for sale, right? You cannot do that. So the patterns that, there I said, the maximum peak is happening, in certain months, right? It is happening somewhere in August. The peak is happening somewhere in August, right? And every year it goes up and comes down. January it starts, it goes up, and you see this hump also, right? It goes up and comes, around the same month. And what is the last pattern in this data set? It is progressively increasing, right? It is progressively increasing. It is this that you need to be aware of, right? So if you're going to predict the future, what will you do? You will predict something like this. right? You will predict something like this. So how are we detecting? So AI, we are trying to predict the future. Always, right? Here, of course, for the sample, I put 2015, it can be any data, right? So what we did here is, this is future. So I am predicting the future, right? How am I predicting future? By detecting patterns. So this is how AI works. Please note that, right? So AI works by detecting patterns. And that is the way, you are going to be, if let's say you are all, going to be planning managers, you're going to be manufacturing, discipline, for all of that, right? You will detect patterns, right? Today it is used in variety of industries. It is used even in disease prediction, right? What are the kind of diseases, people are going to get? How are they predicting? They are predicting heart disease. We are predicting cancer. We are predicting diabetes. How are we predicting? We are predicting by detecting useful patterns, right? So there is one more aspect you all need to be aware of, right? I began this session by saying, I'm going to talk about machine learning. Then what is this AI? How are the two related? Right? AI is like a vision statement, right? Like what the professor said, Delhi Technological University should be, similar to the institutions abroad, right? That's a vision statement. DTU should be the number one institution in India. That's a vision statement. How are you going to do it? That is where machine learning comes, right? So AI is the larger objective, that is to bring human intelligence into a software. Machine learning is the technology that drives this objective, is the core technology, right? So machine learning is the technology that drives artificial intelligence. So please understand that, right? Of course, people are using these two terms a lot. And you should also understand about strong AI, weak AI, right? What are being shown as Rajnikants and Shah Rukh Khans, right? That is not AI. Where we are today is we are solving problems by detecting patterns. Okay. Now, what are the applications? I'm going to come to the mechanical industry, but you must know what are the different areas. I mentioned about healthcare, right? We are detecting diseases. We are detecting fraud, right? Let's say you take a vehicle, I'm sure many of you may be staying at your home, day scholars or hostelites, right? While taking your two-wheeler out or taking your car out, right? You bang against, your wall, right? Or the gate. But how will you log a claim? You will say that, sir, somebody banged my vehicle and went away. I'm not saying you mean, some people do it, right? That's fraud, right? No accident. While taking your vehicle out, you banged against, your gate or against a wall. That's a case of fraud, right? Can organizations detect? Yes, I can detect. Right? With a fair degree of accuracy, we can detect fraud. Today, that is happening. Insurance companies are using it to detect fraud. Right? Sometimes even criminal cases are there, right? All those things machine learning can be used to detect fraud. Right? Let's say you are staying in a hostel. What kind of products a typical MTech student will buy can be predicted using machine learning. And what kind of products will an MTech student buy from a retail store just before the exam on a weekend? That can also be predicted. Because it is all about patterns, right? We identify patterns and we use it to predict the future. right? So now let's come to the mechanical, the core mechanical, right? Industrial analytics, machine learning is used, right? So we want to take it to industry 4.0. What is this? Can anyone tell me what is the name of this equipment? This is a picture of a factory. What is the name of this? Yeah, correct. This is a cooling tower, right? And this is where all the assembly is there, right? All the core manufacturing happens in this setup. So this is possible. So possibly what, 2 floors? How much this will be? Possibly 40 floors, right? So suppose some mistake happens, right? Suppose some mistake happens in this. How will you find out? Traditional method is you wait for the mistake to happen. Then you correct it. The problem is, if your, let's say, assume for a moment cooling tower is a critical equipment. What is a critical equipment in a factory? Critical equipment is, if it fails, for some reason if it fails, the entire factory has to shut, right? Which means no production, which means there is loss to the company. We don't want that, right? So using predictive maintenance, that is machine learning techniques, I can predict when my equipment will fail. That is the beauty of machine learning, right? I don't have to wait. Let's say you are having a two-wheeler or a car, right? What if I tell you next week this particular component is going to fail? How wonderful, right? It is possible. What I am talking is very much in the realm of possibility. Okay, it is already attempted in electric cars. All you need is data. Electric cars, one of the things we are trying to do is, how can I predict when the particular part will fail? In fact, this is already used in the airline industry, right? Let's say, for example, you are going from let's say Delhi to London. Okay, let's assume this is a British Airways flight, and after this London flight is going to the same flight, right? Because it's not like they change the flight. You are going from Delhi to London, that is, the flight is going from Delhi to London, and after that London to New York, this flight has to go. Okay, the same flight. This flight will be in this London airport only for what, 90 minutes or 1.5 hours. You embark, you disembark, you get down the flight, you go to London for your work, right? In 90 minutes this flight will be going to New York, because they follow what is known as hub and spoke model. Okay, that is from different, for British Airways, London is the hub, right? You come from different places to London, and from there you go. So a flight needs to be in flying condition. Let's say, for example, an important component is giving problem, right? What will you do? You can't ground the flight, no. You can't say that sir, we will repair the flight and then we will send people to New York. People will ask for hotel accommodation, they will ask for food voucher, because airlines have to give accommodation if there is significant delay. So previously that's how people used to suffer. Now what is happening is, companies like Boeing and British Airways will be monitoring the flight parameters in real time. Okay, if something is expected to fail or something is giving trouble, the part is identified even before the flight is in London, when it is airborne. Okay, when it is airborne, the particular part is identified. The repair engineer will be ready with the part. As soon as the flight lands, the part is replaced and you move on. Right? That is where the machine learning is going, right? Because we don't want breakdown, and all that, right? And moreover, in a large factory, right, the high impact failures, right, will typically have low frequency. Right? It is like if you are a bright student, right, a topper, right? A topper is there. A topper may also fail in a subject, right? Possibility is there. A topper who is consistently studied well, throughout from school to college to PG, that student can also fail, right? But it is a low frequency. Maybe that student will fail only in one exam out of what, maybe thousands of exams that individual takes, right? Possibility is there. That is how it's a low frequency event but high impact. It will be very damaging, the topper will feel really bad. No, that is how it is for the critical equipment. So ensuring the uptime, right? You are driving, a two-wheeler or a car, right? You need to ensure the car is running well. Okay. And still there are many equipments that are monitored manually, right? We are talking of industry 4.0. Even big companies, right, they have equipments that are monitored manually. So that is where, monitoring assets, we move from preventive to predictive. Okay. And that, the existing techniques to identify failures are non-destructive, statistical process control. And this tool, you don't require specialized skill because you have the machine learning application working in the back end. All you have is an interface, right? A computer interface. And many companies don't have historical failure information or very limited failure information. And this is reality. Because for machine learning, you need lots and lots of data. Please note that. Right? This is where the industry is growing. This is where the industry is going. Right? So the other thing that you need to be aware is, right, you say that, sir, you say, AI is the vision, machine learning is the technology. How will I use that? You need to learn something like a Python, as the programming code. Right? But today we are moving from, suppose, just to develop, I'm just giving an example. You all know IRCTC website, right? To book train tickets.
Yes.
To develop this IRCTC website, right, say when I started my career 25 years back, you probably have to write 30,000 lines of code. Right? That is code heavy. In low code, we are possibly talking of, say, about 10,000 or even 5,000. Right? Because many things are automated. In no code, we are talking of zero code. Absolutely nothing. Automation is not just happening in mechanical industry, it is also happening in the world of programming. Because what is no code? I have automated programming, right? It is programming that drove automation, right? It is only because of computer programs that you can operate machines automatically. But automation is happening to the programming also. You can call it as reverse automation. Right? So that is the tool I'm going to demonstrate. It is through these no-code approaches, automobile no-code approaches, that you can learn machine learning. Even a mechanical engineering student, electrical engineering student, instrumentation engineering student, chemical engineering student, they all can learn. Civil engineering. You don't need to know Python programming, right? If you are interested, you can learn. Right? But there will be many people who say that, sir, programming is not for me. It's not my cup of tea. Right? So how do I do that? I'm just demonstrating this tool. Okay. I just log in. So this is the interface that you are seeing. Okay. So I'm going to demonstrate, what is known as multiple regression and also demand forecasting. Okay. This is a cloud-based tool. That means it is hosted on internet. I don't have to, I just have to give you the login ID and password. You can start using it. Okay. Let me demonstrate this. I'll click one of the things, multiple regression I'm going to do. Okay. So I'm going to put an automobile multiple regression. So I have selected it, right? What is this model all about? I have car model, I have the volume of the vehicle, I have the weight, and I have carbon dioxide emission, right? This is historical information, right? So the model learns, right? Machine learning, computer learns the patterns that contribute to carbon dioxide emission. So next time when I feed in car model volume and weight, it will automatically predict carbon dioxide emission, right? So I have uploaded it. Upload is complete. This is the data that you are seeing, right? So I am now going to select what is the output variable, what is known as the dependent variable. That is, what is it that we are trying to predict? We are trying to predict car model. Okay. So let me choose car model, right? And now I will choose what are the factors. What are the factors? It's car model, volume of the vehicle, and weight of the vehicle. So that's what I'm going to choose. I've chosen volume, weight, and car model. It is all just a drop down menu. That's all. I have not done anything. I uploaded, chose my dependent variable, and I'm choosing my independent variable, right? And now I can see the summary. Lot of information like what is the first quartile, third quartile, right? For volume, weight, what is the type of variable, all those information are there, right? And then I want to see the correlogram, right? What is the extent of correlation between carbon dioxide emission and weight, carbon dioxide emission and volume? If it is closer to 1, that means the correlation is high. We are seeing a very high correlation. What is happening? The model is learning, right? So I have test results. It gives an accuracy of approximately about 33%. This is only a test data, right? It's only a test data, so the accuracy is low. When you feed in, the real life data, the accuracy will be higher, right? So now my model has learned. This is again another, known as an element of accuracy, okay, that is expressed in percentage terms. Okay, I have these things, where the model has learned. Now I want to predict, right? What do I want to predict? I will feed volume, weight, and car model. I want to know the carbon dioxide emission quantity. How will I predict? Because the model has learnt. What is the name of the model? Multiple linear regression, right? That is the name of the model. So I'm going to feed one where only the car model, volume, and weight is there, right? You see that this field is empty, right? So let me choose this. I have this. This is a simple file, so it came very quickly, right? If you load a large file, it will take a bit of time. That's all, right? So the predicted information is what is the predicted? That is the carbon dioxide emission. I can download this also. Now the same thing, I can do a computer program, right? I can do the computer program. I can develop using Python, or I can use any software. But a mechanical engineering discipline students, you don't need to know programming, right? You need to know the concepts. You need to know the accuracy. You need to know how to infer this value. You need to know how you can predict, right? So let me show you one more thing, in the forecasting analysis. So here what I'm trying to do, I'm trying to forecast the future, right? I'm trying to forecast the future. So I will upload the data, right? If it can be used in demand planning, right? Automobile sales. So I am uploading this file. TS data. Forecasting, the loading is complete. How many forecasting you want? This is a daily data I have loaded for past 5 years. So 365 into 5, right? So I have 10 data points that are there now, but I want 365, right? Because I want to predict. So I just enter 365. So I'll say, let's go, right? Are you sure that the data is uploaded? Yes, sir, it's uploaded. We will wait for this to be complete. Okay, file is bit huge, and you have the results here, right? So this is the forecasted data. And what is this gray that you are seeing? This is the upper bound and the lower bound. Whenever you are forecasting, it is always on a range, right? If let's say I come and ask you, hey, how much you have written the exam, how much marks you will get, if I ask you, what will you say? Hey, I think I will get about 80 to 85, right? Some will say I will score between 60 to 70. So what is that? So this is this is the upper, and this is the lower, and this is the average of the two. This is how the forecasting happens. So what did the model do? It learned the patterns, right? It is going up, coming, it's going up, coming, it's going up, coming. So I have information until 2021, I fed it, and I have for the 2022 all the information is there. So I will use this information, right? If you are the manager of an automobile plant, right, you need to forecast you could be asked to decide the model, right, that has the least carbon dioxide emission, so you can predict it. You need to know the future sales, so that you know which are the things you want to store in your factory, right? Right, automobile has got thousands and thousands of parts. It is not like like a clothes store, right? Even that person makes a lot of judgment calls, right? If we all wear different types of shirts. I wear a full sleeve, somebody wears a half sleeve. You need to plan for everything, right? You need to plan for design, you need to plan for fit, you need to plan for size. Because when you walk into a shop, right, that sells shirts, if your particular size is not there, what will you do? Hey, it's not there, let me go to the next shop. So the shop loses, right? Same thing happens in the world of business also, right? For large organizations. If I don't bring scientific way of forecasting, if I don't bring scientific way of detecting failure before happening, that is a loss to me. The world has existed even before, right? Here I talked of industry 1.0, right? Before that we had bullock cart, right? People lived, people made money. But what has happened in 3.0? Productivity has improved. With computers, productivity has improved. When productivity says, the economy grows, right? When the economy grows, more people become rich. You know that, right? More people, when more people will become rich, economy has to grow. See, in any economy, certain people will be super rich. We are not talking about that. We are talking of average people. Why the salary level of people, even computer engineers, you can take mechanical engineers, right? Even a kindergarten teacher has increased, right, in the last 25 years. Why? Because the economy has grown. When the economy grows, and what is behind the growth of the economy? It is productivity. And what has driven productivity? It is industry 3.0, computerization. Now what is going to drive? We have already reached the peak. So if the productivity has to increase further, what needs to happen? 4.0. What is happening in 4.0? We are talking of machine learning, right? So this is how we are operating. This is how it works, right? So I will bring up that particular video that shows AR VR in a minute. If you have any questions, you can ask me.
So there is no sound coming from the video.
There is no sound. It is just some background music, that's all. So let me just pass here. You see here what is it is just a video of the sound, right? There is nothing. If you see here, what is the person doing? He is wearing what is known as virtual reality glass. Okay, there are a lot of glasses that are available. Okay, the famous one is HoloLens by Microsoft. Okay, once you wear the device, I can visualize this entire thing in 3 dimension. Let's say as part of you have to learn about a particular equipment, right? You can bring the entire here I'm talking of steel sculpture with just a click of a button, and you are all sitting in a conference room, right? Let me show that. See, the same sculpture, your professor, let's say, wants to explain about an equipment. How will you explain? Today he will use a computer, right? In his previous 10 years back, 15 years back, he would have used some sheets, right? Projector sheets he would have used. But what is the current thing? It is about AR VR. So bring the entire equipment. See here, they are all sitting in a conference room, right? And you can rotate it. You can understand how to operate it. If it is a cooling tower, how will you go inside a cooling tower? Right, I told you it is 40 floors. Not everybody will go inside, only some specific people will go. And let's say you have joined recently. How will someone train you in cooling tower? So you have this, this entire thing in 3 dimension, right? You have this entire thing in 3 dimension, where you can see this here. He is operating. Right? It points to a lot of things. Right? If somebody wants to give a demo of a tool, you don't need to worry about that. So what I showed you is known as augmented reality. It's not virtual reality. Virtual reality, you just see it in 3 dimension. Augmented reality is, I bring the real life object into a conference room. That is where the technology has grown. I'm sure in future, right, maybe another 5 years, I am not in Delhi, right? Arunjit is not in Delhi. We are in different cities. We will be there sitting right next to you through AR, right? My own, my own image of myself will be there.
It's a metaverse.
Yeah. See, in metaverse also, they are talking of only, like avatars and all that. But I am talking of a technology, right, where my physical presence itself is there. Right? Where augmented reality, metaverse is going, right? It's all physical boundaries. Right? Let's say, today this is already, people are exploring, right? If a complex operation has to happen on this machinery, and let's say that particular expert is available only in, say, Singapore. Assume a scenario. For the person to fly from Singapore to Delhi, right, it will take about 7-8 hours. But it is a critical component. What will that person do? That individual can use augmented reality and have a discussion with you. And similarly, if you are, let's say, the expert sitting in Delhi and a failure has happened, let's say in oil rig, in Singapore, how can you do it? You can, through augmented reality, you can do it, right? So this is the technology of the future. right? That is something very important, to mechanical engineering discipline. With that, we will conclude this session. Thank you.